So, Volker, here we have a nice collection of defective component parts. For example, a flywheel with heavy grease egress on the reverse must be replaced. One thing that's always important, check if the balance weights are still there and if they are damaged. They could be detached a little bit. If so, it must be replaced. Blue coloration on the friction surface might be misuse, like pulling a heavy load back and forth, or maybe they reversed up a hill. Anyway, the clutch was heavily overloaded. Overheating to above 280 degrees will result in this blue color. The temperature even discolors the rivets, damaging the material so much that they can shear off while driving. Defective. It definitely has to be replaced.
Good.
We checked the rock outside, remember? In the case of this rock, it's not clear if it is within the tolerance limit or not. In this case, it makes sense to check and make sure if it's okay.
In this case, I'd say...
I know, I measured it earlier on. We have almost 4 millimeters. That's defective for sure.
Okay.
We can see another damage pattern in this flywheel. The secondary mass has been displaced, which means that the bearing is totally worn out. It has been caused by misalignment. When aligned correctly, the crankshaft and the gearbox shaft have to be in line. They must align with each other. Whenever we have a geometrical deviation in parallelism or axially, the material is overloaded with each crankshaft rotation, and it clearly wears out a lot faster. In this particular application, the mounting position of the starter is on the gearbox side. If everything is parallel, the pinion perfectly grips the ring gear. Whenever we have a geometrical deviation, axially offset for example, the pinion does not grip straight but at a slight angle. And when you look at the pinion of the starter, you can see abrasive wear. Let's go, we'll move on to the clutches. The gearbox shaft is not parallel but at an offset angle, so the material is heavily overloaded as well. This force transfers to a secondary mass and damages the bearing.
I would say replace.
Definitely. That's why it's important to check and replace the spigot bearings if necessary. They are press-fitted on the engine side. Look for damage, rust or anything like that. It's extremely important.
Okay.
We can see a further damage pattern on the back of this flywheel. There are radial cracks and cracks towards the outer edge on the primary mass. This would imply that the crankshaft bearing is defective. You have to imagine it like this. The shaft starts vibrating as well, and the flywheel tumbles back and forth in this bending and reciprocating motion. A bending of 0.5 millimeters is okay. Everything above this measurement results in radial or outer edge cracks. Here we can see the end result, completely torn off. If you ignore this and only replace the flywheel, it may result in a broken crankshaft because there was too much load on the crank.
Yes, but not everybody has a collection like this in the workshop. Can I look up these examples of unusual damage anywhere?
Yes, the information can be found in our DMF brochure or online at RepExpert, the online workshop portal.
Oh yeah, sure.